So glad to be here, and thanks for the introduction. Let's get started. I will start or begin with a question like how many of you have used large language model so for any of your projects or day-to-day tasks? Just raise your hand just to get a count. Super. How many of you have thought, like before using the large language model, there could be something more grave to think upon, could be ethical consideration, privacy breaches, and the risk associated with the AI? That's cool. So let's get started. So my talk will be including, because many people have talked about large language models, so I will specifically focus upon what we are doing with LLMs and why everywhere we are seeing LLMs floating, then how the evolution of the LLMs happen in the due course of time, and then what is this current hype of the LLMs? What could go wrong when we are using LLM for everything? And what are the other methods which we can use LLM for in terms of mitigating bias, which is one of the pertaining problems in machine learning pipeline when we talk about end-to-end predictions or classifications. We will also discuss how we can use large language model in psychology, mental health, diet coaching, and all those intricate domains which are also low resource domain and complex in nature. Moving further, we will also address how hallucination and stochastic parroting appears in LLMs and what danger they could bring to your data or the entire pipeline. We will also identify some sources of bias and the potential strategies that can lead to mitigation, and overall, how we are making a step toward responsible AI. So this is a picture that's more symbolic for the Italy, like if you see, there is an olive oil and which is used for every kind of salad and everything. This is the current state of large language model. You name it, and it is being used. From writing reports, code generation, code debugging, writing reports, medical advices, counseling, and ChatGPT and models like them went to law school. They were rumored to be passing exams of medical exams, a 3-stage examination, a very complex one. It also went to the law school, and there are some snippets I put for the reference, which you can see are indicative that ChatGPT in specifically is subjected to those kind of exams. But what exactly when we are subjecting a large language model to these complex exams is indicative of? Those exams are not the real exams. They are the sample of some of the questions. They are a portion and a standardized exam modules that were the only part that were subjected to the ChatGPT, and passing it doesn't necessarily reflect that ChatGPT is able to understand the context and the intricacy of the domain, or just for that, it will be able to pass those complex exams. So I'm not going to explain this slide. This is just for you to have a look. You can see how the evolution of the large language model over the period of time has happened from 1950 to 2023, or let's say 2024. And not to forget, and important to mention, is 2018 when the BERT, attention is all you need. That changed the entire course of natural language processing. This is a graph which shows the hype of the LLMs about its productivity, what are the kind of the task it has been engaged for, and in what capacity it has been being used. This is from, of course, it is not generated by me, it's from the Gartner. And the problem is that we are made to believe that AI can be enforced to do everything. The sheer volume of the hype across business and social media has attracted executive attention, and often corporate teams are being asked to use LLM, where already the system is efficient, optimized, and introducing the large language models or AI-centric methods would only increase the cost. So this has been the hype of the entire LLM over the period of time. And we forget at that point of time that there could be some challenges. So I'm going to specifically focus on two of the challenges, which is one is the contextual when we talk about the language, and the second one is the ethical concerns. When we talk about Medicare and clinical domain, then there are challenges such as informed consent, privacy, ownership, false information, and contextual concerns are multilingual challenges, so that if you have a text of many languages, that could pose some problem to the large language models, hallucination and stochastic parroting. Hallucination in particularly cannot be confined with one definition, but just to put in brief, it could be considered as the false information, which I will show in successive slides how hallucination and stochastic parroting is manifesting in the pipelines or when we use large language models. To give a quick reference, there is a picture which has A, B, and C, three words that tend to have different meaning over the period of time. So a model needs to be trained over a massive data spanning over the years and the decades in order to understand the context. This is just one example. There could be many possible examples existing at the same point of time. Another challenge, languages are complex. The only difference between human and the AI system is that humans have an innate ability to infer the previously learned knowledge right at the time when we are discussing or we are doing a conversation, which is not the case with a machine. So it may happen for two different languages, the number of tokens required to understand a certain context could be very, very different, could be significantly small or could be significantly large. So that is one of the challenges which large language models do face if they are not trained properly on a massive data to actually understand the context. So let's talk about what could go wrong. So I'm showing you an example. I tend to have an interest in reviewing a lot of papers from top venues and conferences. And this happened once that experimentally, I have been trying to get a review of a very complex paper. And I asked ChatGPT that could you do a review for this paper. Apparently, that paper was only between me and the reviewing system. But somehow, ChatGPT was able to infer the entire paper and provide review with the name. So that is one of the dangers I am pointing towards. How come a manuscript, which is only submitted in a portal, which is just for the reviewer and the chair, can come out in open without the consent of anybody else? Or where is the leakage? That's my concern. So that is one of the potential dangers in academia. Another dangers which we would like to talk about in terms of clinical setup. Once ChatGPT invented a sexual harassment case, a scandal, and named a real law professor as the accused. ChatGPT was once asked experimentally, I am referring to those points, what could be a solution to end the miseries of your life? And a straightforward answer was, if you could end your life, all your misery will come to an end. So what I am referring to is the subtle problems and dangers associated with the unsupervised use of large language models. So I'm going to demonstrate these dangers through two use cases. The two are disjoint. The two are entirely different domains. One in agriculture, one is the military psychology or criminology, or you can say in general mental health. And the two use cases have different research objectives. At the end, we are trying to find the problems associated with the large language model, and also how we can mitigate the biases that manifest in the machine learning system when we are trying to make predictions, classifications, and other NLP downstream tasks. So the three essential questions which we are pointing towards is, to what extent we should use large language model? Can large language model be a real therapist? They can be used in real time. Can you trust the conversational therapy or the dialogues or the counselings which they are generating? Can they be trusted? Can they be real-like? And the third and the most important question for those low-resource domain where data is scarce in nature, and can we somehow use large language model meticulously in order to bridge those gaps in generating data sets and resources to further train deep learning models in order to bridge this gap? So starting from the first use case, the first one is what you are seeing is right now is a bias-aware pipeline. And if you just have a look at it from the end to end, you will see that there are several different kind of biases that are originating at different stages of this entire pipeline. To name a few, if there are multilingual context in the data, then it could lead to contextual bias, linguistic bias, language bias. If the data is skewed in nature, if the classes are not distributed uniformly, that would lead to class imbalance. There is one peculiar challenge which I found while doing the experiment with this particular data is usually the transformer models are built to process the sequence length of 1024 tokens. So what happens to the text that is beyond that? So let's say if I am given a report, electronic health report, or a hazard or incidence report, that spans to a very large text. So what you are going to do, how you are going to process. If you are going to cut some part, if you are going to summarize those parts, they need to be efficiently done in order to preserve the context. So there are several different kinds of biases which manifest in this entire pipeline, and that is very centric to a particular classification problem or particular data set. So this entire pipeline consists of two things. One is the classification, and second, iteratively thinking how those classes can be balanced in order to mitigate certain biases, not at all of them. It's not possible to mitigate all the bias at once for real. So I took help of large language model in developing an annotation scheme in psychology, and it is built upon my data set, which I released 2 years ago. It's called NOMI with my team. It is one of the only data set available in psychology domain, which is GDPR compliant and free accessible. Feel free to reach out to that data. So we designed with the expert psychologist a 2-level annotation scheme. It's actually 3-level, but we will, at this point, consider it as a 2-level. So one aspect, consider the linguistic capability of the large language model, which they are subjected to generate the motivational interviewing, the counseling therapy dialogues. And another was the linguistic aspect. So how sound, how contextually close to the real ones, how the text is enriched when you are using the large language model, and if there is any enhancement happens. So for instance, drug abuse and alcoholism may be very different in real life, but they fall under one umbrella. So it is important that when you are generating the dialogues which are related to these two issues, should clearly depict that. Otherwise, there are chances that they might get overlapped, and there is a certain context deviation. So empathy, non-judgmental attitude, competence of therapist, ethical conduct, reflective, so those are the standard parameters adhering to the MISC coding scheme, which is across the world used for doing the psychotherapy. So these were the two parameters. So what exactly we did is that based on the original motivational interviewing, I will call it MI, those MI dialogues, which were 133 number, and out of them, 120 were the high quality, and 11 were the low quality, 13 were the low quality. For real, there is no low quality counseling data, but in order to make the machine intelligent to understand what psychological notion is missing while doing a psychotherapy, it is important to draw a distinction. So that is why we trained synthetically kind of a role play in order to contrast how the original and could be like a bad MI could look like. So this is a pipeline where iteratively you are using a large language model to generate MI dialogues, and based on those annotation scheme, we are annotating the data, and a new data set is developed. So what next? So we need to evaluate that what was the performance of large language model in this entire role play when we were generating real-like MI dialogues. That need assessment, that need evaluation, and a very critical eye on it. So in this process, we will also look upon that how prompt engineering is important, or how prompt engineering, we can leverage prompt engineering in order to generate good quality or less realistic MI counseling. So on the left-hand side, this is an initial prompt with the feedback of human in loop, let's say psychologist. It is refined over the period of time. So this prompt is used to generate MI dialogues, and this one is the outcome of it. Uh, Moving further. So there were two things which we did. One, we generated the real MI dialogue, and then we also subjected large language model to generate precise summary of those MI dialogue, giving them some ideas. So starting from zero-shot learning to few-shot learning, we gave them some notions that how you should write the summary, what point you should incorporate, and those points were decided by the expert annotators, those psychologists, so that they will be able to understand when they compare that whether those summaries are appropriate or not. Later in the successive slide, I will tell that why summary, we put so much effort in generating the summaries and evaluating it. So this is the outcome. So as we see that, of course, augmentation helps, and it helps in reducing the misclassification error. It gets better representation to the misrepresented classes or underrepresented classes. Here, the table on the right-hand side shows that these are the ratings for the original MI, and the ones which are in the red are deviation from the original one when a large language model has rated. So we use large language model to actually do the annotation, and those annotations are being compared with the original one, and there we see certain deviations. But if we look objectively onto it, you will see that the difference is only either +1 or -1 on a scale of 5. So let's say for one of the MI dialogues to all kind of attributes, psychologists have rated 5, 5, 5, 5, 5. And ChatGPT has, or any large language model has, rated it 5, 4, 4, 5, 4, something like that. So if you look into the context, the deviation is very small, and it is still falling into the same category. So for instance, if the Likert scale says that very relevant, relevant, average, not relevant, entirely different. So relevant and very relevant are still very close to it. So it is getting close to like a human capability of generating the dialogues, or capability of participating in a real-time conversational therapy. The second use case is more centric to generating data by different means, by different methods. Because it may happen if you use multiple large language models, that is not cost-effective on the first place. And secondly, if you are using them, there might be a significant overlap in the context, like the way ChatGPT or Gemini or LLM is generating the data, they might be very similar in nature. So instead of using many models, we preferred here to use one model in different way to generate a different kind of data. And the reason behind it is this table which you see. So we define 4 parameters, which is sequence length, diversity, structural change, and class imbalance. And we decide those 10 methods of data generation based on that. So the ticks which you see is particularly indicating to that attribute. So for instance, if we do text summarization, and if it is very precise, we are overcoming the bias of sequence length. On the same time, if we do a style transfer, and if the size of the report or the EHR reduces, that still is going to help you with the sequence length, the bias that arises in the machine learning pipeline. Before moving to where LLM exactly shine, let's say I work with the domain adaptation, so I'm very much into developing ontologies and knowledge graph. But for real, I know that it's a very labor-intensive and time-consuming process to develop right from the schema and develop an entire knowledge base. And then also, you don't know that how relevant it is. If you generated a knowledge base, you need to know like the particular domain which you are focusing, how relevant it will be to. So we did some experiment with the large language model, and you can see from the refined prompts that there are pretty decent and nice and understandable triples being generated, like the subject and the relationship and the object, the RDF triple, which we call. So here it reduces a lot of human effort, and all you need to do is take out a representative set of this knowledge graph and get it evaluated by human in loop. The key insights are, of course, the data we generated is plausible. It mitigates several bias, contextual bias, language bias, multilingual bias, sampling bias, and all those biases. It contributes definitely to the responsible AI. and it can help in reaching the low resource domain. The practical example which I wanted to give is that, for instance, the country where I work, per 1,000 soldiers, there is only one psychologist available. And we all know that soldiers and officers are subjected to different posting areas. It could be UN posting, it could be hard posting, it could be very difficult posting in some African region, and they might suffer PTSD, homesickness, disciplinary issues. There could be many things. So what exactly I'm planning to use, or I'm using large language model in here, is exactly to flag those conditions where, through an interactive channel of discussion, we can identify, we can do the early identification of those cases where a soldier or an officer could possibly suffer from such flagged situation, which I mentioned, PTSD, and get immediate attention from the psychologist who is the commanding officer or somebody based in their command office. So this process needs to remain entirely confidential, but there, the waiting time right now for one soldier to getting a psychologist appointment is somewhat still, kind of 3 to 6 months. So that could lead to several problems. So that is one practical aspect where we are using large language model. Of course, it is not in the civil domain yet, but I thought that it is relevant to mention in order to evaluate the capabilities of large language model and to use them more responsibly. Thank you. The dataset is available publicly on the GitHubs, and feel free to reach out.